Good morning, students. So, day 25. Today we are going to do alternating current. Okay. What alternating current is? We finished yesterday. What to say? EMI. Yesterday EMI. So, how alternating current is produced? The device is called generator. AC generator you can call it as AC generator. And what happens in that? There is a coil which we are rotating in constant magnetic field. There is a coil which we are rotating in constant magnetic field, right? So, if there is a magnetic field like this, we are making it to rotate. So, what is happening because of that? We are making it to rotate, maybe clockwise or anti-clockwise. Voice is not audible. Now it's audible? Okay. So, we are rotating this coil in constant magnetic field. Okay. So, what's happening because of that? The angle between magnetic field and area is changing. Area's angle is always what? Perpendicular to the plane. This plane is here. Okay. So, area will be like this. Not exactly like this. Not like this. Slightly tilted in this way. Okay. When it will be fully in this side, then area will be like this. So, area is changing its direction. Magnetic field is same. So, because of that, what is happening? We all know that flux is BA cos theta. Okay. So, if this theta changes, obviously flux also is changing. So, if theta is changing, theta what I will write actually? Theta I will write as omega t. Theta is omega t. So, flux we are writing as BA cos omega t. Okay, and if we differentiate that, get d phi by dt, then what we are getting? BA omega sin omega t. And if there are n turns in this coil, then we can write this as minus nBA omega sin omega t. And what this is? This is EMF. And what this is? This is its maximum value. So, maximum value of EMF induced depends on what? Number of turns, magnetic field, area of the coil and angular velocity of the coil. Okay. So, this E we write as what? E naught sin omega t. E equal to E naught sin omega t. And normally EMF is used to say is minus d phi by dt. If it is minus, then what will happen? This minus and this minus gets cancelled. So, this will come out to be positive. Okay. So, this is E equal to E naught sin omega t. Now, it is a sine function. So, we know that how it will be? It will be in terms of sine function only. It will be like this. Okay. This is sine curve. Exactly same way, if suppose I want current. Okay, current will be what? If suppose that this coil is having some resistor or resistance, then I will be equal to E by R. Okay, I will be E by R. So, what you will write? I equal to E naught by R into sin omega t. Okay, so same graph is there for I also and same graph will be for E naught or E also. Okay, so same graph. Only thing is the value, this is called I naught. Okay, here E naught by R we are representing with I naught. So, if we make it here itself, then it will be something like this. Okay, this is I naught and this is E naught. Okay, so this is what we are getting in AC generator. Now, the question is this only AC or do we have any other value or other type of AC also? We have other types of ACs also. what we can do, let's see then. Through graph, we'll try to see that what other type of AC is possible. Okay, so one type of AC is this. Okay, then like this. So that means for some time it was positive, sometimes it is negative. That means direction is changing, right? You can say this is I only, I and T graph. So for some time it was positive and then it becomes negative and again it will become positive and then again negative. So this is also alternating current, but its magnitude is constant. A constant magnitude alternating current. Okay, same way another one we can make. Another one. Okay, now in this one suppose current is like this. So here also what's happening, for some time it is positive, then it is becoming negative. But in this one more thing is there, that the current's magnitude is also changing. So alternating current with variable magnitude. This is alternating current with same magnitude or constant magnitude. This is with variable magnitude. Okay. This is alternating current with variable magnitude. And this is alternating current with constant magnitude. With constant magnitude. Okay. So both, or in fact all three, are actually alternating current, 1, 2 and this 3. But our concentration is mainly on this one. Mainly on this one. Because we are producing it through generator, and generator is the primary source through which the current in our home is coming. Okay. Alright. So now we will see what is average value of alternating current. Now why we require average value? Because current is changing every moment. It's variable. Now how to find a particular, a specific value for a current? Okay. So then thought of average value. So average value is what? Average value is one which depends on time. Why depends on time? Because average value, if we say average speed you find, so what you will say? Distance traveled per unit time. So if time is half an hour, time is 1 hour, time is 1.5 hours, average value changes. So that's why average value of any quantity which is variable depends on time. So what time, what is average value actually in this one? What do you say? So average value of current, which I am writing like this. This is actually what? The flow of charge per unit time. Okay. Flow of charge per unit time. This is actually average value. Okay. And if suppose it's given in terms of graph, then we'll say area under graph of IT curve, current and time curve by total time. This is average value, right? Now, if suppose I have to find average value, okay, if I have to find average value, and if I know the current, what is current? We know that I equal to I naught sine omega t. Okay, I naught sine omega t, and we know the graph also. How is the graph of current? It's a sine curve. So sine curve, when it is given, that means we cannot find the direct area. It's not possible for us. Then what to do? So to find the area, we have to integrate. What do you do? I dt. And in the denominator, you can take directly how much time is given, or that also we can integrate if you want. Like this. So I dt by dt. Depends on what time interval you are taking, we can take that. If flow of charge is given directly and the time is given, we can find from there also. Okay. So I dt by dt. This is average value, right? And then what is there? RMS value. This is what we use normally for AC. Okay, because it depends on heat developed. How much heat is getting developed across the resistor we have to find. Okay, so how to find? Who gives us value? Average value or this? Average value, there is a problem that in a complete cycle, average value becomes 0. Okay, so that's why average value we don't take. Now see, area of this one. Okay, this is a complete cycle up to time period t. Now here area is positive and here area is negative. We add both, it becomes 0. It becomes 0. So because of that, average value of current in one full cycle comes out to be 0. In half a cycle, we definitely get the value. Okay, but that is not giving us the value that we want for heat generated. We want heat generated. Heat generated normally is what? I square R dt. Okay, so correct value for heat generated comes out from IRMS value. And IRMS is what? What is IRMS? It's the root of mean of squares. Mean of squares means I square dt by dt. Now this is mean. Mean means average. Whose average? Square's average. And then square root. That is IRMS. Correct? So here, if you are going to solve this one, this is I naught sine omega t square dt by dt for a full cycle. Okay, what we are getting? We get I naught by root 2. I naught by root 2. So if this is a sine function it is we are taking, then we are going to get I naught by root 2. Even if it is given I naught cos omega t, same answer. I naught by root 2. So this value we have to remember. This is our RMS value. Right? Let's see first question then. So it's given that V equal to 100 root 2 sine 100 pi t. Now in this one 100 root 2 is what? Its maximum value. E naught. Okay. So its maximum value here. V naught value is 100 root 2 volt. Okay. And this is coefficient of t. That is omega. So omega is 100 pi. Okay. Then what he wants? Find RMS value of V and frequency. Frequency we want first. Okay. So frequency, this omega is given. So we know that 2 pi into frequency equal to 100 pi. Pi is gone. Frequency is equal to 50 hertz. Okay. So one thing we got already. Now it's RMS value. What will be RMS value? Now it's a sine function. So RMS value should be maximum by root 2. So ERMS or VRMS is 100 root 2 by root 2. That is 100 volt. Simple question. RMS value is 100 volt, frequency is 50 hertz. Right? Okay. Right. Now see that one alternating current is given, and in that one we can see that it's not sine function. It's in the form of triangle. Okay, and what the question is asking, what is I average between t by 2 and t? See, if suppose he would have asked us in total time period how much is average current, we would have said 0. This is positive area, this is negative area. It's 0. Okay, but what he has asked, t by 2 and t. So t by 2 and t means I have to find this area. Okay, and if suppose we want to write it also in this way. I average we want to do from t by 2 to t. Okay, that will be equal to what? That will be integration I dt by dt. Though here we are not going to find integration as such, we will directly do it. Okay, because area is known to us. This is I naught minus I naught. Okay, so what is area? Half base into height. Okay, so base is what? T by 2 and height is I naught. So this I dt's value we have already 1 by 2 I naught into t by 2 by time. How much interval? T by 2 to t. That means t by 2 only. So answer is I naught by 2. Answer is I naught by 2. Certain times this this will be given in such a way in which you have to write the equation. Equation also will not be given, and graph also you will not be able to find. Okay, so then you should be able to write the equation. Some coordinates will be given, so you should be able to write equation of the line. Then only we can solve it. Now suppose instead of this, it would have been given to you like, um, do we have it? Okay, I'll try to frame one question. Okay, then we will see. So suppose that a graph is given to you. This is I. Okay, and the graph is given to you like this. Only this. Okay, so maximum value is given. I naught. Okay, and here time is given. Some time. This is here t, and here maybe t by 4. And they say find its average value itself. Then what you will do? How to find? This we can say is area again, area of the triangle. Okay, but in place of this, if it's given in this way, like this, now what to do? Now what to do? Here also you have to find area only, but provided you should know what the shape is taking place. Now we can say here what the shape is. If this value is given, we can find area of this rectangle, then area of this triangle, and we can solve. Okay, so it depends. Okay, normally with us it will be given in such a shape so that we can find the area very easily. So I don't think there will be much problem in that, right? Okay, let's see next question now. So here a phase difference between V and I is pi by 4. Phase difference between V and I. They are not in same phase. But when we produce them through AC generator, both were in same phase. It was V equal to NBA omega sine omega t, and I also was V naught by R sine omega t. Okay, so they were in same phase. But he says if phase difference between V and I is pi by 4 and frequency is 50 hertz, then the phase difference will be 0 in how much time? Okay, so what to do? So we'll say that let's assume V equal to something like V naught sine omega t and I equal to I naught sine omega t minus pi by 4 you can write, or plus pi by 4 you can write, that's your wish. Okay. So here phase difference is pi by 4. Say okay. Now how we are going to cover it up? Time factor only, because there is no displacement happening. Coil is rotating. So time factor only. So delta phi, who is going to decide? Say omega. Omega delta t only is going to decide. Okay. So omega delta t is going to decide. So this is what? This is 2 pi by t into delta t into pi by 4. Pi gets cancelled. So delta t is going to be t by 8. Okay. So after t by 8 seconds, there are chances that both will be in same phase. Now this t will be decided in terms of frequency. Now frequency is given as what? 50 hertz. So if frequency is 50 hertz, then time period is 1 by 50 of a second. Okay. So this delta t is 1 by 50 into 8. That is 1 by 400 seconds. So after 1 by 400 seconds, both will be in same phase. Okay, according to the question. So here who decides that phase, how to change the phase? Only omega delta t. Remember that. Okay. Alright. See this one now. I equal to 10 root 2 sine 100 pi t plus pi by 6. Find time in which I value increases from 0 to I RMS. Okay. The initial value of I is 0. And it is increasing to I RMS. Now I RMS is what? I naught by root 2. Okay. I initial value is 0. I RMS is I naught by root. Okay, now who makes it these values here? Only sine function decides, because we know that I equal to I naught sine omega t. This is here. I equal to I naught sine omega t. So if I consider that t equal to 0, you have I 0. Then after how much time you are going to get this? Or after how much traveling of the angle you will be getting this value? Let's say 45 degrees. If this is I naught sine omega t, forget about this function at the moment. If this is I equal to I naught sine omega t, at t equal to 0, I is 0. Okay. Now when this will be at I naught by root 2, when this is 45. So omega t is 45. Correct or not? So we'll write that only. Omega t is 45 degree. That means whatever is initial value, from there you have to rotate by 45 degree. Okay. Then you are going to get I naught by root 2. So again what? This is 2 pi by t will write. And this is pi by 4. Pi gets cancelled. T equal to t by 8. Okay, frequency or omega is given to us already. Okay, 100 pi directly I could have written. Okay, so 100 pi you are writing means this is going to be again 1 by 400 of a second. Okay, because here 100 pi you will be writing. 100 pi, pi cancel, t equal to 1 by 400. So after this much time, current will increase from 0 value to IRMS. IRMS means I naught by root 2. Okay. Okay, see now what's happening. This is a junction. Okay, from here this AC is coming and from here this AC is coming. Question is asking what is this? Okay, so now we all know that what happens at junction, right? Incoming current is equal to outgoing current. So this plus this will be this. But how to add this 3 sin omega t plus 4 cos omega t? And what is the phase difference between the two? One is cos function, one is sine function. Phase difference is 90 degrees. So actually we are going to add simple harmonic motion, because this is simple harmonic motion equation also. So how we learn to add simple harmonic motion? Same way we have to add this also. So 3 is here, in vector form we have learned. This is 3, this is 4. Okay, angle is 90 degrees, so resultant will be this. Okay, what will be resultant? Resultant will be 5. Resultant will be 5. And then there will be definitely phase also. So what you can say, this I is definitely 5 sine omega t, now plus what? Plus theta. From 3, it is theta degrees ahead. 4 was 90 degrees ahead. This is theta degrees ahead. Okay, now theta is what? Now theta is, we can find this as tan theta equal to 4 by 3. Because we can shift it over here. This is a right angle triangle. This is 4. So tan theta equal to 4 by 3. So our equation is coming I equal to 5 sine omega t plus tan inverse 4 by 3. That's all. That. Okay. So 2 AC we are going to add in the same way as we added 2 simple harmonic motions. Right? Okay, fine. AC circuits are there. Now AC circuits, what we want to do in that one, it's similar to DC circuits. We want to calculate all those things. What is the potential drop? What is the current in this one? Maybe how much is the power? How much is the heat generated? These all things we want to calculate in any AC circuit also. But in this one, there is one difference between what we did in DC and AC. In DC, V and I, there is no phase difference. They are always together in the same phase. So we didn't have any problem. But in AC, there is phase difference between the two. Because of the elements that we are going to use, or maybe because of the production, you can have certain phase difference. So phase difference are there. So to calculate it, we require phasor diagrams. Phasor diagram means is a graph between potential and current. Okay. So what we do? We make the graph here. Okay. Now current, we always take it along x-axis. Always along x-axis. Okay, and we will be making phase with that. Some phase difference we will make. Suppose V is over here. Okay, so this is theta. Okay, we'll say that V is theta degrees ahead of I. V is leading. Okay, if this is V, and we say V is leading, shall we write? Okay, V is leading current by theta. A phase difference between V and I is theta. But if suppose that V and I both are together, V is also here, then we say V and I both are in same phase. V and I are in same phase. Okay, now suppose I is given to us as I naught sine omega t. Then what will be V? V will write as V naught sine omega t. They are in same phase, we are saying. Here what you will say about V? Here you will say V equal to V naught sine omega t plus theta. Okay, if there is 90-degree phase difference, then also no problem. We'll make it like this. This is 90 degrees. In this case, we'll write V equal to V naught sine omega t plus pi by 2. Okay, so this is basically a phasor diagram which shows you what is the angle between current and the potential drop across any element or across the circuit itself. So we show it through phasor diagram. Okay, right. So let's see. If we have only resistor in the circuit, what happens? When you have inductor, what happens? When the capacitor is there, what happens? In an AC circuit. Okay, so only resistor is there. Alright, so only resistor. It's like this. And you have, this is the supply. And supply is what? V equal to V naught sine omega t. And this is resistor. Okay, so what resistor does? Is it going to produce any change in the phase? Answer is no. Okay, this doesn't produce any change. So V and I here across resistor, they are in same phase. Okay, V and I are in same phase across resistor. So it means I will be here I naught sine omega. Okay, and I naught is actually what? E naught by R. I naught is equal to E naught, not E naught, V naught here. V naught by R. They are in same phase. So when I have to put in phasor diagram across resistor, what I should do? The phasor diagram will be like this. Current is here because we show it like this only. And then along with that one, potential drop across resistor. Both are in same phase. This is I, this is VR. Okay, they are in same phase. Inductor. In inductor's case, phase changes here. Here phase changes. What phase changes? In inductor, potential drop across inductor lead the current, because we know that inductor actually opposes the change in current. How it opposes? By producing the EMF, right? So first EMF will produce across inductor, then only current will flow. So in this one, current lag. Okay, current lag behind potential drop across inductor. So if I am writing as I naught sine omega t, or okay, I we are writing as I naught sine omega t. Then VL you'll be writing as what? V naught sine omega t plus pi by 2. Current is behind, current lag behind potential drop across inductor by 90 degrees. So I equal to I naught sine omega t, this VL is V naught sine omega t plus pi by 2. So if you have to make the graph, what you will do? This is I and this is VL. This is I, this is VL. This angle is 90. Same thing is capacitor. Capacitor, what happens? Capacitor, this is not inductor. So capacitor is like this C, okay, and we are connecting it across alternating source. Now what happens in capacitor? Now capacitor, as you connect it with the source, it starts charging. So when charging starts means immediately current has come. What about potential? When it is charged, then potential will come. So first charge deposits, then potential will come. So first current, then potential. So in this one, current lead, potential drop across capacitor. Potential drop across capacitor. Okay, so if I write I equal to I naught sine omega t, I am writing I is I naught sine omega t everywhere, okay? Because that we have decided that we are going to put horizontally in the phasor. So I am not changing its phase. It's always I naught sine omega t, okay? Then what is VC? And VC will be V naught sine omega t minus pi by 2. Okay, its graph will be, here is I and here is VC. This is 90. Okay, so phasor diagram is like this. We saw that all the three, resistors, inductor and capacitor, all three phasor diagrams I have made for you. Okay, now what we can do? In resistor, all three I'll again make in separate way. Here is resistor. Okay, here we'll do it for inductor and then we'll go for capacitor. So here resistor. As we said that there is no phase difference between current and potential drop in this one. So we can make it in the same way only. Okay, two graphs if you have to make. This is for V and this is for I. There is no difference in that. Okay. Now what relation will be there? Because only resistor is there. So in this one we can say V naught will be equal to I naught R. I naught is what? Maximum current. But VRMS will be IRMS into R. Simple. If the current is I naught, then V naught is this. If current is IRMS, then we are going to get VRMS across. In inductor's case, what will happen? In the same way. Now this is current. Okay, this is I. Now what happens for the potential here? We say potential leads. Okay, so potential will start from here, like this it will be. Okay, I equal to I naught sine omega t and VL equal to V naught sine omega t plus pi by 2. Okay, we have to find what is V naught in this case. And this one V naught is I naught into its resistance. Its resistance is XL. This XL we call as inductive reactance. Inductive reactance. Right, and its value is what? XL actually equal to omega L. Okay, same way VRMS will be IRMS into XL. Okay, VRMS will be IRMS into XL. V naught was I naught into XL. Here we have written in terms of R, so there is no problem in this one. But here this is XL and XL value is omega L. So it means resistance. This is basically what XL's unit is what? Ohm. Okay. Unit of XL is also ohm only. XL unit is ohm. Okay, because this is also offering resistance to current. So resistance to current we are measuring in terms of ohm only. Okay, but its resistance depends on omega. If you are changing the omega, resistance changes. Alright, the same way capacitor, this is inductor. Now here is capacitor. Okay, in capacitor's case, if we can make the graph, this is I naught sine omega t. Okay, so IT curve. Then how it is over here? So it starts from here. It's like this. What is this? VC and T. Okay, this is VC and T. So what we can say this is I naught sine omega t and VC equal to V naught sine omega t minus pi by 2. Okay, so I naught is, or rather V naught, not I naught. V naught equal to I naught into XC. Okay, and Vrms will be Irms into Xc. Xc is what? Xc is capacitive reactance. Capacitive reactance. And its value is 1 by omega c. Its value is 1 by omega c, and it also depends on omega. If omega is more, this is less. If omega is more, this is more. Okay, so because if its resistance is less at less omega, this is called low pass filter. Its resistance, when its resistance is less, it will easily allow the current to go. Okay, so this is called low pass filter. Which one? Inductor. Okay, this is also known as low pass filter. What is the meaning of that? At low frequency, its resistance is less. Okay, whereas capacitor, it's called high pass filter. This is high pass filter. It allows the current when frequency is more, because when frequency is more, its resistance become less. So it allows the current. Okay, so this is low pass filter and this is high pass filter. All right, we have discussed about capacitive reactance and inductive reactance. All right, now see, this is a question. A general question is there. We'll try to solve it. So what question is asking? One inductor is there or solenoid is there and one bulb is there and it's connected across AC source. The question says if iron rod is removed slowly from inductor, how brightness of bulb will change? If iron rod is removed slowly from inductor, then how brightness is going to change? So first thing is, when you are talking about the iron rod, if iron rod is there, then what will be the magnetic field inside? Because L, if suppose L we are going to talk, what is L? We said it's phi by I. Okay, phi is what? Phi is mu Ni into area, some pi r square by I. Now I am writing mu here, I am not writing mu naught. The reason is because iron rod is there. Okay, so permeability became different, and we know that mu definitely is more than mu naught. So when you have iron rod, L value is more. When L value is more, it means XL value is also more. Okay, because XL is what? Omega L. So L is more, that means obviously XL is more when iron rod is here. But when you are removing it, when you are removing the iron rod, you are decreasing the value of L. So when you decrease the value of L, that means its resistance is going to decrease. When its resistance is going to decrease, there will be more current in it. Current will increase. If current will increase, this will give you more light. Okay. What you'll write? Then answer is what? If iron rod is removed then XL decreases, more current goes through circuit, and bulb glows more. Bulb glows more. Very simple. Okay. Now similar question I'll give you. Now this time it's with the capacitor. It says if dielectric is slowly taken out of capacitor, how brightness of bulb is going to change? Okay. Same question, but in capacitor this time. Okay. So what we are going to do? Same way, when capacitor is there, that means its capacitance will be on the higher side. Because capacitance is what? K epsilon naught A by D. In this case right now, capacitance is K epsilon naught A by D. And if you remove this dielectric, so capacitance is going to decrease. Okay. On removing dielectric, capacitance decreases. Okay. Now XC is actually inversely proportional to C. Forget about omega. Omega we are not changing. XC is 1 by omega C. So if you are going to decrease this C, that means XC is going to increase. On removing dielectric, capacitance decreases and XC increases. Now if you increase XC, current will decrease. Current through the circuit decreases. So brightness of the bulb is going to decrease. Okay. We will write over here, since XC increases, current decreases. So bulb will glow less. Okay, so bulb is going to glow less. Okay, then what? What's next? Now combination. Okay, the combination L and R together. So LR circuit. So what we have in LR circuit? LR circuit is like this. Okay, now we know that when we talk about current, let's say current is same, I equal to I naught sine omega t, we are not making any change in that. Okay, so if current is I naught sine omega t, then we know that across this the potential, there is VR, that will be I naught R sine omega t, because it does not create any phase change. Okay, but here in this one, we know that it creates phase difference between potential and current. Okay, and in this one, potential is 90 degrees ahead of the current. So VL, what will that become? V naught sine omega t plus pi by 2. Okay, so you can see that the potential across this and potential across this is also having phase difference of pi by 2. So we have to make phasor diagram. We have to show it, right? So where is this VR? VR is in the same way as I we made. So VR we will make here, horizontal. Okay, and where is VL? VL is here. VL is here. What is the resultant? Resultant will be like this. You have to add it vectorially only. Are these vectors? No. But according to phasor diagram, they will be added in the same way as vectors, right? So it's like this. This is V, resultant. Okay, and this is phi or theta, you can say. Okay, so this phi is what? You say 10 phi equal to VL by VR. VL by VR. Okay. And what is this V value? V actually is VL square plus VR square. Okay. V's value is VL square plus VR square. Correct? Now, if suppose we want to know net resistance of this, so net resistance also we can make in the same way. What I can say, this V, this is only magnitude. This is for the magnitude. So this V, we can say, if suppose we want to write in terms of maximum current or we want to write in terms of RMS current, it's our wish. Okay. So suppose in maximum I am writing, so I naught into Z. Now this Z is what? We call it as impedance. So I naught into Z. VL is what? I naught into XL. We have seen that before. I naught into XL square plus I naught into R whole square. That is square root. So I naught we can take common and cancel it. So Z equal to what? Z equal to root over XL square plus R square. Now what this Z? This Z is called impedance. Okay, Z is what? Impedance. That means net resistance of AC circuit we represent in terms of impedance, or we write in terms of impedance. Okay, so impedance, Z is impedance. Okay, net resistance of AC circuit. So from here we can also calculate what is already I have written, V equal to actually I naught Z. Okay, so what this is? This will be V naught, remember, maximum value. The VRMS, then VRMS will be IRMS into Z. Okay, this is which one? This is LR circuit. Same way as RC. In RC, what happens then? This is R and this is C here. And this is supply. Again, same way I we are taking as I naught sine omega t. So VR will be what? I naught R sine omega t. No problem in that. But across C there is a problem. What problem is there? The capacitor creates phase difference. Then what it is? I naught XC sine omega t minus pi by 2. Minus pi by 2. Okay. So in this one graph is like this. But in this one graph changes. Here is VR. And then here is VC. Okay. And resultant is this. This is V. And this is phase. Okay. So what we can do? Same way. V will be equal to root over VC square plus VR square. Then same way we can write, if you want Z value here will come out to be XC square plus R square. This is V naught, or V naught or VRMS, your wish. Okay, so VRMS, if I have to write over here in this case, VRMS will be IRMS into Z, and V naught will be I naught into Z. Okay, IRMS into Z or I naught into Z. Exactly same way what we have done over here, same way is over here. So these are LR and RC circuits for you. Okay, let's solve few problems on this one also first. Okay, see then problems. Okay, one extra sheet was there for it. Okay, LCR also at the same time. Okay, let's see LCR also. After that only we'll solve the problems. Okay, leave it. Okay, so L, C and R. Okay, as usual, I is I naught sine omega t. L, C and R. So this time what we have to do? We have to make all VC also, VL also and VR also. So where is VR? VR we know that it doesn't create any problem at all. So it is I naught sine I naught R sine omega t. So where we are going to make it horizontal along with I. So this is VR. What VL do? It makes potential to go 90 degree ahead. VL. So VL is here and VC is here. So if we combine all three, okay, if we combine all three, we'll make it a little smaller. Okay, this one I'll take up. This is VR. Okay, and this is VC. Right, now what? Now combine. So these two are 180-degree out of phase. So if suppose in this one also there two different ways we can make it. If VL is greater than VC, possible? Then what you will do? The graph will be like this. Here is VR, then it will become VL minus VC. And if VC is greater than VL, then this is VR and this is VC minus VL. Okay, when VL is greater than VC, VL is greater than VC, it is called inductive circuit. Inductive circuit. And if VC is greater than VL, it's called capacitive circuit. Capacitive circuit. Clear? So in this one, VL minus VC is here, VR is here, so resultant will be here in the middle. This is the resultant. This is V, and V will be equal to what? VL minus VC whole square plus VR whole square. Here resultant will be where? Okay, and theta is also there. Theta will come here. This is, let's say this is phi 1 and this is phi 2. Okay, this is V. Now here V value is what? Here value is VC minus VL whole square plus VR whole square. Okay, what is here phi 1? So you write 10 phi 1. 10 phi 1 will be what? VL minus VC by VR, and 10 phi 2 is VC minus VL by VR. VC minus VL by VR. Okay, Z value, because we know that we can write this as I naught into Z. So this will become I naught XL, this will be I naught XC, this will be I naught R. So Z value in this case, it will be same only both the cases because this term is in square. Okay, so Z value comes out to be XL minus XC whole square plus R square. This is Z. That's the impedance. Okay, so this is LCR. Let's solve problem now. So here it is only inductive. Inductive circuit it is. He is asking just inductive reactance, nothing else from us. Okay, very easy question. So inductive reactance means what? XL. XL is actually omega L. Omega is 2 pi frequency into L. What is frequency given? 50 Hertz. Okay, by the way, what is this 220 volt? This is RMS value. Okay, RMS of supply. Supply voltage RMS value is 220. Whenever it's given in this way, it is RMS value. Okay. So what this is here? 2 pi into 50 into 50 into 10 to the power minus 6. So this is already 2500. 50 into 50, 2500 into 2. 5000 pi into 10 to the power minus 6. So 5 into 10 to the power minus 3 pi ohm. This is the value of inductive reactance. Okay. Alright. In LR circuit now, what is there in LR circuit? In LR circuit, L is given to as 1 by pi Henry, R is given 100 ohm, I RMS value is asking. Okay. So L is given and R is given, and I RMS is asking. So L and R, that means there is your inductor is also there and resistance is also there, but V is not given. So we will take V. Okay, no problem in that. So we will say that supply, if suppose we make a diagram for this one, if we make the diagram, here is L, and there is R, okay, and there is supply, okay. So first of all, what you'll do is, we're going to calculate what is XL value. So XL value is omega L, okay. So for omega L, I require this one, okay. So what you'll do, you'll take it as 220 volt and 50 hertz. Same value as it was in previous question, okay. So what is omega L then? Omega L is 2 pi into frequency, which is 50, into L value, that is 1 by pi. So pi and pi gets cancelled, it is 100 ohm. Okay, resistance is also given to us as 100 ohm. Then IRMS will be what? So LR circuit's net resistance impedance we have to find. What is impedance? Impedance is root over XL square plus R square. That means 100 square plus 100 square, that is 100 root 2. 100 root 2 ohm. So IRMS will be what? VRMS by Z. What is VRMS? VRMS 220, where it is here. 220 by 100 root 2, 100 root 2 ampere. Okay, 220 by 100 root 2 ampere is our IRMS value. Clear? Okay, let's move ahead. Again, LR circuit is there. This is 120 volt across inductor and 50 volt across resistor, and 3 ampere is current. Which current? RMS current. So he is asking what is V. V is what? VRMS. Okay, this is inductor, this is resistance. Now the potential drop across inductor and potential drop across resistor, do they have phase difference? We say yes, 90-degree phase difference is there. So then V will be what? We know that what is V. What will be V? Sorry. VL square plus VR square. Correct or not? VL square plus VR square. So what we are going to get? This is 120 square plus 50 square. What's going to come? 130. 130 volt will come. Okay, 130 volt is going to come. 120 square plus 50 square is 130. Clear? Now, suppose Z is also asked from us. What is Z? So, what do you say? VRMS equal to IRMS into Z. VRMS we already got 130 volt. VRMS is 130 volt. So, 130, IRMS is given 3 into Z. So, Z equal to 130 by 3 ohm. Okay, Z equal to 130 by 3. Okay, see this now. There is this inductor which is connected across DC, 100 volt, 2 ampere current is going. Same one, this is same. Okay, same inductor when connected across AC of 100 root 2 sine omega t, 1 ampere current is flowing through this inductor. The question is asking you find Z value. Okay. All right. So in DC, when you are talking about inductor and 2 ampere current is flowing, that means there is 2 ampere current there in inductor. So is inductor going to oppose then? No, its opposition is already over because constant current is going in it. Then how to find, this is 100 volt, this is 2 ampere, then resistance how to find? As I told you yesterday, that there are inductors which have resistance. Inductors must have resistance, but resistance must have inductor? No. So this definitely is having resistance. That's why 2 ampere current is possible. Otherwise, if it's a pure inductor, it's not possible. Okay. So it is having definitely resistance. So in first case, what we can say, we start its solution. In the first case, we'll say this I is basically V by R. In DC it is, so Z is not there, R only. So I is 2 ampere given, V is 100 volt by R. So actually resistance of this inductor we are getting from here, and how much is that? 50 ohm. This is resistance of the inductor. Now let's go here. Now you can make it in this way also, and if you want you can put a resistor of 50 ohm also there, because both are going to be used in AC. So here what is there? 1 ampere current is there. And what the question is asking, Z. So first thing that we need to find in this one is what is L value? What is L value? Or directly we can find Z, that is also fine. No issue in that. Okay, so you can see what is given here. This is I value, should be V value. Okay, this is V. Okay, so then we have to find what? Z value. So what is Z? Z we can say is, if suppose V naught we want, so V naught also we can take. V naught by I naught. But here is even 1 ampere, that is constant value. So it is RMS. You say okay, Z value is also V RMS by I RMS. What is I RMS? V RMS. V RMS is given 100. So that value we already know. That is 100 by 1 ampere. So Z value is actually 100 ohm. Now question is what is L? If they are asking you what is L also, then what to do? So Z value actually is XL square plus R square root. And this is 100. Okay, so what you will do? You will do Z square equal to XL square plus R square. So this is 100 square. R square means 50 square equal to XL square. Okay, so 100 square means 10,000. 10,000 minus 2,500, it will be 7,500 equal to XL square. Okay, so XL value is coming root 7,500. Then what we want? We want L value. Okay, so XL value is root 7,500. That means omega L. So L equal to root 7,500 by omega ohm. This will be our answer. In this one, omega is not given, so that's why we have kept in terms of omega ohm. Okay. So this is how we can solve. So remember that whenever DC is connected, that means that information is there to gather how much is the resistance of inductor. And once you know the resistance, then it's pure LR circuit. Through LR we can find whatever is the question asked from us. Okay. Right. Okay. Now see this one. This is LCR. LCR connected across alternating battery of 50 volt. This is RMS value. Okay. What is given across L? You are measuring a potential of 60 volt. Across capacitor you have got 100 volt. So what is the current in the circuit he is asking? What is the reading of ammeter he is asking? Okay. So what we know in an LCR circuit, this is V, no? So V actually is what? Either VL minus VC whole square plus VR whole square, or other way around, maybe VC minus, but here what? Yes, this is VC minus VL. VC minus VL I am writing. Why? Because VC is more. Okay, this is given 50, so fine, this is 50. VC minus VL is what? 100 minus 60, that is 40. Plus VR square. So 50 square minus 40 square equal to VR square. 2,500 minus 1,600 is 900. So 900 equal to VR square. That means VR is 30. VR is 30 volt. And resistance is 10. And he is asking current. Very simple. VR will be what? IR. So I is equal to 30 by 10. That means 3 ampere. That's all. Work is over. Okay. Alright then. Next is again LCR, but this time what is he asking? He is asking potential difference across L, C and R. Okay. V is given to you 100 root 2 sine 100t and L, C and R values are given. Alright. Okay. Now across R, first of all we will talk about across R. VR. Now what is VR? VR we will say that is I naught sine omega t. But in this case, supply is given like this. So can we say I is like that? We will not be able to. Okay, because we do not know how is the current going in this one. With this supply, its current is also having some phase difference. There is a possibility. There is a possibility of that. This is V. This is the supply. Okay, but still, what I am going to do is I am going to write this is I naught sine omega t plus theta. We will write. Okay, if there is any phase difference over here. Okay. Sine omega t plus theta we will write. We will see that. We'll see why it's like that. But this is VR. Just let me write it as I naught first. I value. I is equal to I naught sine omega t plus theta. Okay. Then VR is what? VR will be I naught R sine omega t plus theta. No issue in that. Okay. Then what? Then VL. VL will be what? I naught XL sine omega t plus theta plus pi by 2. We know that. We see I naught XC sine omega t plus theta minus pi by 2. All in terms of I only I have written. Nothing else. Okay. Now the question this is what is this theta? Whether I is ahead of supply or I is behind the supply. You have no idea. Okay. So what he will do is first of all I am going to find out what is the impedance of this. That we know already how to find. The Z value XL minus XC whole square plus R square. Correct? We know that. So XL what? Omega is given to you as 100. Okay. XL is omega L. Omega L means what is there? 100 into L value 200. That means 200 ohm. XC is what? 1 by omega C. That is 1 by 100 into 1 microfarad. That is 10 to the power minus 6. So this will become 10 to the power minus 4. It will go at become 10,000 ohm. And resistance is given 100. So we know that what it is. So this is XC minus XL actually. 10,000 minus 200. 9,800, right? 9,800 square plus 100 square. A big value is there. Okay. I'm not going to calculate now. We'll leave it. Okay, this is the Z value. But still, what is phase difference here? Between supply and current. That is what theta we have done. Once theta is known, everything we know. Okay? Everything will be knowing. So that theta only we have to find. Correct? So now theta, let's find theta here. So we have the place. Okay. Here only we'll try. Okay. So now if we make a phasor diagram here, we know that this is VR. Okay, and here is VC minus VL. Why I am writing VC minus VL? Because we have seen that XC is a lot more than XL. So VC minus VL. Now here is V. Which V? This. Okay, and we all know that current is in same phase as VR. They don't have phase difference between the two. So that means if this is VR, that is also I. Okay, so this is theta basically. So actual thing is current is ahead of the supply by theta. So we have written absolutely right. Here this is omega t and this is omega t plus theta. The current is ahead. Now what amount it is ahead, we can clearly write. Tan theta is there. We know how to write tan theta. Tan theta is Vc minus VL by R or Xc minus XL by R. Xc minus XL by R. That is theta. So we can write over here and we know everything now. Okay. VL, what is the phase difference of VL from V? That we can write. How much it will be? Theta plus pi by 2. Whatever theta is coming, plus pi by 2. What is the VC? Theta minus pi by 2. Right? So this is how we can easily find out what is the phase difference. So that's why this phasor diagram understanding is important for us. Okay. Here I gave you a little awkward value of capacitor. If it would have been comparable, we could have found out. But no issues. We can still calculate it. Okay. So these are the potential difference across LC and R. Okay. Right. LCR and resonance. Resonance means what? Resonance means is in which current and supply are in same phase. Okay. When current in circuit is in same phase as supply voltage. Same phase means this angle between the two is 0 or phase difference between the two is 0. When it's going to happen? When there is only resistance in the circuit. Okay. That means actually XL is equal to XC. This is the condition of resonance. Okay. XL is what? Omega L and XC is what? 1 by omega C. That means omega square equal to 1 by LC. That is omega equal to 1 by root LC. And omega is what? 2 pi F. So that means frequency is equal to 1 by 2 pi root LC. So when frequency is this, our LCR circuit will be in resonance. And in resonance what happens? As I said, Z value will become R. So in this case, the current that you are getting will be maximum current. V naught by Z, which is actually V naught by R. Okay, in this current value is maximum and resistance value is least because XL and XC, XL minus XC has become 0. Okay, in all other cases you will be getting XL and XC value. Something will be there XL minus XC, which will be along with R will become something. But in this case XL minus XC is 0, so you are only getting impedances equal to R and I becomes maximum. That's resonance. Okay. Fine. Let's see what the question is based on resonance now. Calculate C when current is in phase with voltage. Easy question, right? Calculate C when current is in phase with voltage. That means he's saying about resonance. They are in same phase. Okay, resonance means what? X equal to XL. X equal to XL. Okay, frequency is also given to us. So no issues. So frequency equal to 1 by 2 pi root LC. What is frequency given? 60. Okay, so 60 into 2 pi. So 120 pi equal to 1 by root LC. L is given 40 into 10 to the power minus 3 into C. Square this one. 120 into 120 into pi square equal to 1 by 4 into 10 to the power minus 2 into C. Yes, 4 into 10 to the power minus 2. 4 into 10 to the power minus 2 will multiply over here. So 120 into 120 is 144. 0, 0. Pi square is also 10. into 4 into 10 to the power minus 2 equal to 1 by c. We got c value, right? So 10 to the power minus 2 and this 10 is cancelled. So what we have, this is 6, this is 7, and then what? This is 5, 5760 is equal to 1 by c. So c equal to 1 by 5760. Oh, okay. That's it. So whenever he says current and supply voltage are in same phase, that means he's talking about resistance. Okay. It's very hot. Okay. Let's see ahead. In series LCR, the supply potential, supply voltage E equal to 10 sine 100 pi t minus pi by 6 and I is 2 sine 100 pi t plus pi by 2. Draw impedance graph. So what we can see in this one, current is ahead. Okay, this is omega t minus something, this is omega t plus something. So who is ahead? Current. When current used to be ahead? When it is capacitive circuit. Okay, so he's talking about a capacitive circuit. It is capacitive circuit. Draw impedance graph means is draw phasor diagram, nothing else. So what we know, this is VR over here. Then we will be VL minus VC. Or you can write R over here and XL minus XC over here because he wants impedance graph. So R and XL minus XC will write. R and here XC minus XL. Okay, because it's capacitive circuit, so XC minus XC. Then what? Then this is how our E is. Okay, now this value we can find, but this value already we know, right? Phase difference. So what is phi here? Phi is pi by 2 minus pi by 6. How much will come? This is 6 here, this is 3 pi minus pi, that is 2 pi by 6, that is pi by 3. This is pi by 3. Okay, this is pi by 3. Right, what we can do? We can find the relation. We can say 10 pi by 3 is equal to XC minus XL by R. XC minus XL by R. 10 pi by 3 is 1060. 1060 is root 3. So root 3 R equal to XC minus XL. Okay, this is not E actually, I have made a mistake. E will be there when you are writing here VR and VC minus VL. Then E. Here at the moment this will be Z. Okay, so this basically is Z. Okay, now what we should do? Shall we find Z value? Can we find Z? Yes, we can find Z. Why and how? Because this is given, no? This is V naught value and this is I naught value in this circuit. So Z value we know, it is V naught by I naught. V naught value is 10 and this is 2. So this is 5 ohm. Okay, shall we get all other values also? Possible. Z value we have. Now Z value is what? XC minus XL whole square plus R whole square, square root. Okay, so Z is XC minus XL whole square plus R square. But XC minus XL you already have got. What is that? Root 3R. Put it here. So root 3R whole square plus R square, square root. So 3R square plus R square is 4R square. 4R square square root is 2R. So Z value is 2R. Z already you found 5. So R value is 5 by 2. Okay, then XC minus XL is what? 5 root 3 by 2. XC minus XL will be 5 root 3 by 2. This much only we can do. because L and C are not given. And L and C are not given, further we cannot find. Omega is given, but L and C are not there. Okay. So this way we found R value also, Z value also, we made impedance graph also, everything we have, XC minus XL value we have, R value we have, Z value we have. Okay. Alright, let's move ahead then. Power. Power in an AC circuit, or I should say actual power. Actual power is, normally in DC what we say I into V, here also similar, I RMS, V RMS into cos phi, because here V and I are not in same phase. So that's why I RMS, V RMS into cos phi. Okay. Which current? There is actually I RMS cos phi, that current which goes into resistance. Okay. That only will give you the appliance, power to the appliance. Whichever is going into the inductor and capacitor, that energy is actually stored in them. Okay. Because in appliance, when you have appliance is represented by resistor. So which current is going in resistor is I RMS cos phi. So this is I RMS, V RMS cos phi. And what is cos phi here? Cos phi is called power factor. It's called power factor. Now what this phi is same that we were calculating as a phase difference. Answer is yes. Little while ago we were writing 10 phi is equal to something like XL minus XC by R. Okay, if you make the graph also, this is R here, and let's say this is XL minus XC, and this is Z, and this is phi. That same phi only. What is cos phi here? Cos phi is R by Z. Cos phi is R by Z, or in terms of, if you want to write in terms of potential difference, then it is VR by VL minus VC. And according to this graph, if suppose it's downward graph, that means XC minus XL is there. So this will become VR by VC minus VR. It depends how we are making. So this is power factor, and this is the same phase. Okay, clear? So this is the actual power, which is actually we are using in AC. VRMS, IRMS, cos phi. Okay. All right. Let's see then this one here, this question on that one. So LCR 10 ohm, 60 ohm, 20 ohm connected across source of 220 volt RMS and 50 hertz frequency. What is the power factor of circuit? Simple actually. R by Z we have to find power factor. We know R by Z. Okay. So cos phi is R by Z. So Z we have to find. So Z is what now? Z is, now these are resistances given directly. Okay. This is the value of XL. This is the value of XC. Okay. So XC minus XL whole square plus R square. Okay. So 60 minus 10, that is 50. And this is 20. So this is 2500 plus 400. It's better that we should take it as that is possible or not. Better value. Okay, let it be 2500 plus 400, 2900. We got it. Now R value is 20 and Z value is this. We got power factor. No problem. Okay. Now last topic. Last topic on AC. Transformer. Transformer works on AC only. Okay. What is the principle? It works on mutual inductance. It works on mutual inductance. And there are two types of transformer we know, step up and step down. We'll discuss about that. Okay, so this is called primary coil, this is called secondary coil. Okay, number of turns in primary NP, number of turns in secondary NS, and here we are going to get V output. Here this is input, VP you can say. No, this is input. Alright, so when we are going to give here this input, okay, what happens in this one? In this one flux changes, so flux changes through this one also, and because of the mutual inductance in this one, EMF is induced and we get the current also. Very simple phenomena. Okay, so what happens then? We say that the flux associated with each coil is equal. Okay, flux is with each coil is equal. Okay, then what we get out of that? Okay, what we get out of that? We say that the ratio of the potential that we are getting, V output or V secondary use by Vp is actually equal to number of turns in secondary by number of turns in primary. If there are more turns in that, we are going to get more output. If less turns in that one, less output, because we are saying that through each turn, flux linked is same, this one and this one. Okay, so if there are more turns, we are going to get more output. Less turns, less output. So Vs by Vp equal to Ns by N. Okay, and for ideal transformer, we know that power should be or efficiency should be 100%. And normally also in a transformer, efficiency is very high. 98% is very normal efficiency of transformer. Okay, so ideal transformer means 100% efficiency. That means IP into Vp, that means input power, must be equal to Is into Vs. If that is true, then Vp by Vs will be equal to Is by Ip. So here we will put here. So Vs by Vp we are written. So Vs by Vp will be what? Ip by Is. This is the relation we should remember as far as transformer is concerned. Okay, this relation comes from where? As I told you, flux. Okay, flux linked with each one is same. Flux is what? Flux is directly proportional to N. More the flux is there, then more will be EMF generated. Because more flux change is there, more will be EMF generated. Okay, so we have written that EMF is directly proportional to N. So Vs by Vp is equal to Ns by Np. And second factor is coming from the power. Okay, let's do one question also in that one. Np 100, Ns 250, V maximum, V naught is given. V naught input is 25 volts. V RMS output is asked. Okay, we know the relation. Relation is Vp by Vs equal to Np by Ns. Okay, V primary is given 25 volt, it's maximum. Okay, let it be maximum. 25 by Vs equal to Np 100 by 250. So this is 4. So Vs, that's maximum. 250 by 4. Question is asking RMS value. We know how to calculate RMS. Vs RMS is 250 by 4 by root 2. That is it. As simple as that. Sometimes they will ask you in terms of efficiency. So efficiency is output power by input power. So if 60%, so we will say output power. What is output power? Vs into Is by Vp into Ip. Clear? So that way we can find the questions on efficiency also. Last thing about this transformer is step-up transformer. Step-up transformer means Vs is more than Vp. That means EMF produced in secondary is more than EMF produced in primary. That means NS is more than N. That means IS is less than I. Vs is more than Vp, Ns is more than Np, Is is less than I. Step down. Step down means is Vs is less than. That means Vs again less. Ns is less than Np. Okay. Ns is less than Np. But Is is greater than P. At power stations, we use step up transformer. Okay. At homes, we use step down transformer because at home we require more current. At power stations, we don't require more current because we have to transfer it. Okay. So if you're transferring higher value of current, then there will be more power losses. So we don't want that. Okay. So step up and step down. And this is it. That's about AC. Okay. So scan this QR code. Scan it and go through all the things. We have covered everything on which normally the questions are asked. Everything we have covered. Okay. So if you do this much theory and maybe more questions based on that one, that should be enough as far as AC is concerned. Okay, students. So tomorrow we'll touch magnetism and matter. Very small portion is there, and then we'll go into ray optics. Okay. See you tomorrow, students. Bye bye.
Thank you, sir.